Five, four, three, two, one.
All right. Hello, willkommen, bienvenue, konnichiwa, ni hao, jambo, marhaba. It's time for the Armist Inquisition yet again, episode 262 on Sunday, the 18th of December. I'm Phil.
I'm Ben.
I'm Matt.
And we're very happy to be joined by Antonio Zamora tonight. How are you doing, Antonio?
Very well, thank you.
Thanks so much for coming. We touched a little bit on the Carolina Bays when we had the Cosmic Tusk George Howard on, but that's ages ago, and that was like his sort of introduction to this topic of the Younger Dryas and cosmic impacts and stuff like that. So looking forward to sort of digging into the bays specifically and figuring it out.
I watched that podcast, and it was pretty much a monologue.
That's what we like.
Yeah. It means we don't have to do anything.
Yes. But, you know, it's like once you're talking about the Carolina Bays, you cannot stop because it's really the key to understanding what happened at the end of the Ice Age. And when I retired, I became interested in geology, and the Carolina Bays fascinated me because of their regular features. And in 1933, when there was a publication that tried to address the problems of why there were these symmetrical features all oriented toward the southwest. And the proposals were that they were created by a swarm of meteorites. But then when people were looking for meteorite fragments, they couldn't find any. So that was not, that shower of meteorites turned out to be like fake news. And people started suggesting, well, maybe they were created by wind and water. Today, we can actually see using LiDAR that the Carolina Bays are quite complex. You know, you can see the overlaps, you can see the raised rims, and something that is common for all of them is that elliptical shape. And, you know, when you take a look, you see the elliptical geometry is the most conspicuous characteristic of the Carolina Bays. They have raised rims, and they are all on consolidated ground. That means loose dirt. They are all oriented toward the Great Lakes, and they all are within 1,500 kilometers from the Great Lakes. So the ones in Nebraska are called Nebraska rainwater basins. And when you look at the orientation, they are oriented toward the Great Lakes, but they are almost like 90 degrees in orientation relative to the ones in the East Coast.
Right, so some of these are on the east and some of them on the west, but they're pointing to the same point.
That's right. That's right. And so this brings up the question of, okay, if they were not from a burst of extraterrestrial shrapnel, what was it? And in 2009, Richard Firestone suggested, hey, you know, the Lake Michigan and Hudson Bay in Canada look like potential locations from where these originated. And in his in an earlier book, he had mentioned that the ice boulders ejected from an impact on the Laurentide ice sheet had created the base. But then he changed his story, and in 2010, Michael Davies actually started a database of Carolina bays, and he was able to show that they originated around the Great Lakes. In he actually put the focus on he put the focus by Lake Huron, and so it made it obvious that they were all connected, or they were all from one place. Now, Firestone did not do any work on the Carolina bays. His 2007 paper actually just mentioned the Carolina bays as a place from where samples were taken. But his major evidence was the microspherules that had a large distribution.
Right, and these are the impact proxies, they call them, isn't it?
Impact proxies, yes. And when some work was done in South America, they even found these microspherules all the way down to South America in Pilauco, in Chile. And so it's you know, it's a very extensive debris field. The one, the one thing that cannot be denied is that there is a large platinum anomaly at the Younger Dryas boundary. And even though people objected to the microspherules, saying, well, these were from some industrial processes, or maybe from some meteorites that are falling constantly during all these meteor showers. But the large platinum anomaly actually made it more concrete that, yes, there had been an extraterrestrial impact 12,900 years ago. And you can see that this platinum distribution is a little bit wide. So people have been saying, well, maybe there was not just one, but there were several, and they happened at different times. And so that has been a project of discussion. Excuse me. I came into this in 2011 or so, and by 2017, I published a paper in the journal Geomorphology outlining what I thought was had happened, okay? And I call this the glacier ice impact hypothesis. First, excuse me, I'm just recovering.
You've had a bit of laryngitis, haven't you, Antonio?
Yeah, yes. First, a meteorite impact on the Laurentide ice sheet ejected ice boulders in ballistic trajectories. And these secondary impacts liquefied on consolidated ground close to the water table. And the oblique impacts on the liquefied ground created inclined conical cavities. And finally, viscous relaxation reduced the depth of the conical cavities to produce shallow elliptical bays. And fortunately, all this can be substantiated with experiments, right. And that's one of the things that I have tried to do. show some experiments that um, um, also supplement some of the experiments that have been performed by Peter Schultz, for example. And see, let me show you. When I say um,
Oh wow!
exactly, this is why I wanted to show a video.
So what's actually happening in there, Antonio? What's he
Well,
firing into what?
into a sheet of ice.
Into
See,
ice. Right.
Professor Peter Schultz said, well, people have been asking, where's the crater of this supposedly impact on the Laurentine ice sheet? And Professor Peter Schultz said, well, let's have an experiment and see what happens underneath. And after these impacts on the ice sheet, he found that underneath the surface, there was almost no damage. He said a little bit of wind and some water and rain will erase all trace of that impact event, which is what happened in the Great Lakes. All the Carolina bays and the Nebraska rainwater basins are pointing toward the Great Lakes. But where is the crater? Wiped out. We have Great Lakes instead.
And I guess, like, when the ice is melting, I mean, the amount of ice, an ice sheet 2 miles thick is going to wash away a lot of evidence with it of anything that made it to the ground, if anything did.
That is absolutely correct. So I tried a couple of experiments, one of which was impacts on hard ground, and you can see a piece of ice impacting hard ground fragments into many little pieces because the ice is very brittle and it has low yield strength. And so the piece of ice hits hard ground, it just is like rock covers ice, rock triumphs over ice. And but when you take a look at an impact on a viscous surface, it's completely different. That piece of ice stays whole and creates an inclined conical cavity. And so then when the inclined conical cavity through viscous relaxation reduces in depth, you end up with an elliptical feature with raised rims. And so my experiments have tried to show that. See, let me show you some of the experiments.
Okay.
Here, for example, I wanted to show that how overlapping bays are made. You remember that picture that we have here, okay? Notice we have one little bay overlaid by a big bay.
Yeah.
Yeah, and well, how does that happen? Well, it happens like this. When you have one impact cavity next to another one, as you get viscous relaxation, they become shallow, overlapping bays. And, depending on the angle, when you view them from above, these inclined conical cavities are elliptical. And this is what we're looking at when we're looking at the LiDAR images.
And would the two strikes would they have needed to happen in quick succession, or can you determine like the time difference between the two strikes?
Yes, well, I'll get to that. When I discuss the ballistic trajectories. Okay, cool. Right now I'm just showing you the mechanisms by which viscous relaxation erases some of the traces of the impact. Like, for example, some of the critics have said, well, the Carolina bays don't have any shattering or any disturbed foundation, which indicates that they were impacts. Well, And the reason for that is the following. When a projectile creates a conical cavity, and then you have viscous relaxation, the conical cavity is restored from the bottom up. There is a high pressure at the lower levels that starts closing up, and then as the closing of the cavity progresses, the stratigraphy is restored. And so here it shows you 1, 2, 3, 4. And that is basically the way in which that happens. And then we also have irregular bays. And when I looked at these, I had a hard time figuring out how did this happen? How can you have all this irregular bays, all looking like guitar picks? And then I looked at the levels, and I noticed all of these Carolina bays have higher terrain toward the deformed portion. In other words, they were formed on a hill, and when the ground was liquefied, the ground on the top of the hill flowed into the cavity. And I said, okay, can I test that? And sure, I can test that. You know, when you have an experiment, an elliptical cavity, and then you tilt the ground as if it had been formed on an inclined terrain, you end up with some of the viscous material flowing into the cavity, destroying that elliptical shape. And here on the lower left, you have the reason why. The inclination in the penetration funnel is greater on the uphill side than on the downhill side. And as the ground flows downhill, it flows faster into the uphill side, resulting in the distorted bay.
Yeah, it makes absolute sense, doesn't it?
Mm.
Well, you know, one of the criticisms of the wind and water hypothesis, you know, this is an experiment performed by Raymond Kaczorowski and put in a report in 1977. The report was never published in a peer-reviewed publication, but he tried to say, well, they were formed by wind and water, and he said a fan blowing across a circular pool, but he didn't just put it blowing in one direction. He started blowing in one direction, and then he switched it to the other side. And so here he got some arrows showing where the wind direction. Well, this is not something that happens in nature. And the Carolina bays are not pointy structures like he has shown here. So I think that the impact hypothesis is more reasonable than the wind and water hypothesis. We can model more of the features that we see in the Carolina bays. You know, something else that I did was to show that indeed the Carolina bays are elliptical. And I have a program which is on GitHub that actually fits an ellipse to Carolina bays. And so here you can see the data points along the Carolina Bay, and then they fit into a very nice ellipse. So you cannot say, oh, these are oval or whatever. They are ellipses. They are conic sections.
How many bays are there, Antonio? Has anyone counted them all?
Excuse me. An estimate from 1952 from Professor Prouty indicated that there were 500,000, but this was before LiDAR.
Oh my god!
Now with LiDAR, we can say that there are millions and millions.
Wow.
Can we?
You know-
Can you give us an idea of scales? So, like the smallest
Yes.
ones to the biggest
As a
ones.
matter of fact, this one has a scale here. It has the scale at the bottom of this slide says 541 meters. So this one actually in the ellipse says major axis 917 meters. So that's almost a kilometer.
Can you imagine?
See, that's almost
being
1
there, man?
kilometer.
It's raining a million ginormous ice boulders.
So can I just clarify in my own head here? So we're saying something hit the ice sheet and then it exploded loads of ice boulders into the sky.
Right.
Then they hit the ground, these ice boulders, and because they're made of ice, they liquefy the soil and the ground, basically.
Yes.
Right. Okay.
And let me show you. See, there are programs that help you calculate projectile size from crater diameter.
Oh, cool.
These programs were derived from explosions of ammunition and mining and so forth. And so when we apply these equations, which is power law scaling, we can see that a Carolina Bay of 1 kilometer would be made by an ice boulder with a size like Yankee Stadium.
Wow.
Oh my
Yeah.
god!
Exactly. You know,
Do you know?
including all the bleachers. Okay. And so,
Do you know what is the? I don't know if you know this off the top of your head, but what is the furthest distance away from like the suspected impact site? Do you know that?
yes. Well, the fact that we have. Before we go here, let me just tell you
Okay.
something.
Yeah.
Notice how the energy calculated for this impact that creates a 1 kilometer Carolina Bay is 3.03 megatons. Megatons. Now, the Hiroshima bomb was like 20 kilotons. So this is much, much bigger energy.
Would that be 3 million tons of TNT?
3 mega is million, 3 million tons of TNT.
Just for that one crater.
Wow.
Yes.
One of
It's crazy, isn't it? the amount of energy in that is unbelievable.
Right. And now, notice if we take a look at the equivalent magnitude, like an earthquake magnitude, this would be equivalent to a 7.8 magnitude earthquake.
Wow.
And this is important because earthquakes of magnitude 6.3 or 6.0 or higher liquefy unconsolidated soil. And in the earthquake in Christchurch, New Zealand in February 2011, we saw the effects of this. The scars started sinking into the vibrating ground from the earthquake. And so when you have, if I can show that the impact of an ice boulder is of magnitude 6.0 or higher, I know that the ground was liquefied. And so it turns out that any Carolina Bay of 200 meters or bigger had that much energy. Wow. Now, you were asking, how do we know a lot of this? Since we have a convergence point either at Lake Michigan or some other point around the Michigan Peninsula, like Saginaw Bay, we can measure the distance, and then from the width to length ratio of the Carolina Bay, we can tell the angle at which it impacted. So let me show you another slide for a minute here. See, this is shows the elliptical base. And if you take the sine of the angle is equal to the width to length ratio, okay? So we can calculate the angle of impact from the width to length ratio of the Carolina Bay. And to show you, you were asking about the size. Here is a pig farm illustrated on the bottom right next to some Carolina bays. And those are 8 buildings. You know, these are huge.
Yeah, and anything bigger than 200 meters is like a 6-point
Right,
Richter
right.
scale earthquake when it hits the ground.
So
Mad.
the interesting thing about this is that from the bay geometry, which gives you the angle of impact and the distance to the point of origin, which is Saginaw Bay or is Lake Michigan, we can have ballistic equations that can give us the projectile speed, the height of the trajectory, and the flight time. And then with the yield equations, we can calculate the energy. And then using the law of conservation of energy, we can actually figure out the energy of the extraterrestrial impact. If we do this for all the Carolina bays. But
Right. That would take a while.
It'll take a while.
There's a million of them.
This is the empowerment of the laws of physics. But if you say that the Carolina bays were made by wind and water, then you just wave your hands and you don't advance science.
Yeah, or beavers, Antonio. Aren't beavers a contender?
Excuse me?
Beavers. Ziggy down on the chat is saying that some of the mainstream were claiming that beavers were making the bays as well.
Oh, no. I had a YouTube video on that. But beavers only make their nests along streams. Some of these Carolina bays are not in any stream whatsoever.
Yeah, I think that's a bit of a weak argument.
Could it be giant cats? They do look a bit like paw prints.
You know, spawning fish, yes, spawning fish. But see, here we can see the launch speeds for different distances. So we can calculate that the speeds were from 3 to about 4 kilometers per second. See, that's about, what is it, 7 times the speed of sound or so?
Oh my God.
Yeah, so it's like some of these new ballistic rockets that they are playing with in the time of flight from about 6 minutes to about 9 minutes. So this tells you one thing. This helps to tell the story. You have the extraterrestrial impact. And then ice boulders are ejected as shown in that video from Professor Schultz. And 6 minutes after that initial impact, you start having all these Carolina bays being formed. You have this 3 minutes of terror where you have a constant rain of impacts flattening the ground.
Sorry, Antonio. Are we saying that they were all formed inside 3 minutes?
Yes.
A million? What would that? What would that have sounded like?
This is what the ballistic equations tell us. Okay, it's like, you know, I cannot make stuff up like that. You know, you know, the ballistic equations tell us if you have a distance of 1,000 kilometers at an angle of 35 with a launch speed of 3.2, which is what it takes to take it out there, that flight time is 6 minutes. And if you have a distance of 1,470 kilometers at a launch angle of 45 degrees, you're going to need a launch speed of 3.8 kilometers per second. And that flight time is going to be 9.1 minutes. It's going to go a lot higher. You can see this goes 368 kilometers above the surface of the Earth. That's almost as far as the International Space Station, you know? You're going to shoot down the little satellites with all this debris flying up.
Yeah.
I just can't. This is just blowing my mind. We're talking about something like 300,000 Tsar bombers going off in a minute per minute for 3 minutes. I mean, it's just mind blowing. I can't believe that anyone survived this.
Well, you know, this is why in the cover of my book, I chose this picture. Okay. Let me show it to you. Let's see. Oh, I moved that one down. Okay.
There'll be a link in the show notes, by the way. Anyone listening, if you want to check out Antonio's book, just scroll down to the show notes and you can find a copy there on Amazon.
Yeah. Look at this landscape.
Rusty.
You can see it there as well, can't you?
Now, look at the scale mark at the bottom, 5 kilometers. And that Carolina Bay next to that scale is 4 kilometers. I calculated that large Carolina Bay was formed by a boulder measuring around 800 meters in diameter. 800 meters.
Crazy.
I'm guessing because of the amount of. I'm guessing because of the amount of bays.
You know, we're talking about enormous amounts of ice, huge ice pieces being put one right after another.
Yeah.
So I was just going to say these ice pieces. I'm taking it that these are displacement ice from the ice sheet. They're not part of the comet itself.
Right. This just comes from the ice sheet.
Right.
You know, the comet hits the ice sheet. It ejects all these pieces of ice, as shown in that video from Professor Schultz. And those pieces of ice come 6 minutes after that initial impact and start liquefying the ground, creating this viscous ground. Any animal, any person in there gets mired in this muck. They cannot run. And then they get hit by a nice iceberg, you know?
I mean, it kind of explains why, you know, mainstream anthropology, I guess, kind of says that we came over the Bering Strait, because you would think that everyone in North America would have been wiped out of, you know, below the ice sheet as a result of this. You would have thought, wouldn't you?
Right. But take a look at this picture and say, okay, where could I hide that would not wipe me out?
You just go to that pig farm.
No, you'd be wiped out, you know.
Yeah.
Shucks.
And then following this, you have the Younger Dryas, 1,300 years of cold weather.
Yeah.
Because of the what do you call it? The impact winter, you know, from.
Yeah, so I'm guessing as well as like these big boulders that are forming the bays, there would have been a lot of sort of just water vapor and then cloud formation for years and years after that.
Absolutely. And, you know, people have asked me, how do you know that these were formed by ice? You know, ice will melt and it'll evaporate. As a matter of fact, a professor said, well, you know, once you have an impact, all the ice just evaporates. No. As a matter of fact, in order to show that, I ran an experiment. You know, this is the nice thing about geology. You can experiment and see what is the truth. Okay. And so, okay, I looked at how long it would take for an ice boulder to come through the atmosphere. The atmosphere is 100 kilometers thick. Okay. And then at a speed of 3 kilometers per second, you can just divide it out and find out how long it takes for the ice boulder to come through the atmosphere, you know. And so I said, okay, it's just like the reentry of one of these space shuttles. And so which gets to temperatures of about 1,900 degrees Celsius. Okay, I can do that, with this blowtorch. That's about the same temperature as the reentry from space. And so I said, okay, 1 minute of reentry, to come all the way down, how much ice will melt? I could not believe it. It was only 10% melted.
Wow.
What happens is a blowtorch or an airstream that is going against the ice boulder creates a plasma of ice vapor, which protects the ice. And so, and ice takes a lot of calories to melt, so what's going to happen, you have this wave front or shock front that, and maybe that ice block is rotating as it comes down through space. And so it's rounding out the rough pieces. It's breaking up, maybe colliding with other ice boulders. And so, but you also have the streaming, the slip streaming, where one big boulder coming, or one small boulder coming after a big boulder, that other boulder is not going to have much resistance. And so you're going to end up with less evaporation, and you're going to have a lot of these smaller boulders actually reaching the ground instead of just vaporizing in the atmosphere. So, the numbers are really mind-blowing. You were asking about survivability. And, this is a sample of Carolina Bays in Marlborough County in South Carolina. And notice the overlaps. A overlaps B, which overlaps C, and A overlaps D, and E and F, and G is a little bit separate. Okay. Now, by measuring these, here are the measurements. Like A has a width of 881 meters and a length of 1,378 meters. That's 1.4 kilometers, okay? So these are huge chunks of ice coming down and, bigger than Yankee Stadium, making A, B, and C. And then you have the smaller chunks, like D would be equivalent to the Rose Bowl, the Rose Bowl coming down on top of you. Well, anyway, when you add the energy of all this impact, you end up with 7.95 megatons per square kilometer. 8 megatons per square kilometer. And we have saturation bombardment. This is just one small 2-kilometer area of South Carolina. Wow. You're talking of just an enormous amount of energy going down. And so the thing that happens is I want to show here. This is that paper by Firestone and 25 co-authors that introduced the Younger Dryas impact hypothesis. And they said, well, there is a black layer that marks this event. And this is where they've been, below this layer, you have the megafauna. Above this layer, no megafauna, no Clovis people. So this was an extinction event. And then it's right before the black mat, or you end up with all these microspherules that were reported by Firestone. And the interesting thing is that the black mat is on the west side of the United States. Look at this map. This is a publication by Vance Haynes where he shows the black mats. How many are on the East Coast? Not very many. And so I said, this is interesting. Why is that? And so I put a circle of 1,500 kilometers centered on Saginaw Bay, which is what Michael Davis proposed as the impact point of the extraterrestrial comet. And you see, hey, most of this black mat is outside that area of high bombardment. Why is that? Well, it's like when you have an avalanche, you have this cloud of dust, snow dust, that drifts way beyond where the main avalanche ends. And here you're having a bombardment of ice boulders hitting the surface. In the hard ground, they are crashing against each other, creating shards. Shards of ice powder, which drifts along and starts smothering the vegetation like a deep, heavy snow. And the black mats are not from burning. The black mats are created from diatoms and fungi. So for the 1,300 years that the Younger Dryas event lasted, you have this, for the first 200 years or whatever, you have this vegetation covered by the ice powder, which basically just rots, creates a black mat, and then it gets overlaid by more dust to create the modern covering. And what is interesting also, as I said, people have been saying, well, the megafauna didn't die by extraterrestrial impact. They died by climate change. But there's another theory that says the incoming people through Beringia killed them.
Yeah, overkill.
These humans with their Clovis points were such super predators that they killed all the fauna, the camels and the short-faced bears and the lions and the saber-toothed tigers and the mammoths.
Well, they were that hungry. Once they made it over, they were really hungry. So they had to eat everything over 100 pounds.
That's how you get giants.
But see, people are trying to prove it, okay? And this paper in Nature Communications is trying to see where were the people and where the megafauna remains. But notice, in essence, the conclusion of the paper was, well, there's not enough evidence to say that the humans really killed the megafauna. But what is important here is look at North Carolina, the east coast of the U.S., North Carolina, South Carolina, Georgia. How many fossils of megafauna do you find there? Zero. It's a blank slate. Now, when we go back to um, when we look back at this story of the 8 megatons per square kilometer, what does 8 megatons per square kilometer do to megafauna? It grinds them up into a pulp, and which is indistinguishable from the soil. I mean, like, put a mammoth or two in the blender, hit it with more ice, and you have a megafauna smoothie.
Sounds lovely, that doesn't it?
And so this is what happened. This is what happened in the East Coast, where the bombardment was so severe. There are no megafauna remains in North Carolina, South Carolina. This was 8 megatons per square kilometer, and so, all this is evidence. You can make a story like I have made that the ice bombardment killed the megafauna in this 1,500 kilometer area. Further back, here you can see California, a lot of remains there. Why? It was far away from the impact site. And so there could have been survivors out there. They were protected by the mountains, from some of this harsh wind and so forth. So these survivors that stayed out on the West Coast eventually proliferated or came back into this devastated area. And, the Clovis gave way to the Folsom culture. So, I find that this saturation bombardment is really a terrible, terrible thing. And, some people are saying, oh, did you give a question?
I've just thought, I mean, presumably some of these stadium-sized ice cubes would have landed in the oceans as well. And think about the havoc that would wreak with tsunamis and stuff like that.
Well, I thought about that, okay? What happens is you don't have like one great wave, like when you have a tectonic plate sinking, okay? So you end up with do not end up with a tsunami. Instead, you have bombardment, and you have a lot of ripples, some of which interfere with each other. So you end up with a very rough sea, but you don't end up with a tsunami.
Really? They'll sort of cancel each other out then, because there's that many.
Yes. And the Atlantic coast was within range of these ice boulders, and so but right now the East Coast, the current East Coast, is like 190 kilometers further west than it was at the time of this impact, because at that time the sea level was like 140 meters
lower.
The current sea level.
Yeah.
When people say, well, some of this Carolina base could have been formed a long time ago, and some people have suggested like maybe 740,000 years ago. But I look at the current erosion, like for example, in the book by in 1942 book by Johnson, here's a picture, and on the left side is a satellite image from 2020. So in these years, notice what has happened to the rims. They have almost disappeared.
In no time, in half a century.
Well, yeah. So how old are the Carolina bays? They cannot be that old. If you have this much a change in like what is it, like 78 years.
Yeah.
You cannot. They cannot be very old, and by saying that they are like 12,900 years old, that's probably about right, just based on the evidence of erosion.
Now then, Antonio, would this affect the sort of calculations when it comes to deriving the impact velocities and stuff? Because it seems that they will have changed. The bays that we see today will have looked different 12,000 years ago.
What we're seeing from the erosion is not a change in the size of the bays. What we're seeing is a change in the prominence of the elevated shoulders or the raised rims.
Right.
Those raised rims are being dissolved or incorporated by vegetation, but the size of the bay, it has not changed.
Right, that makes sense. So it doesn't affect your calculations in that regard.
Right.
Cool.
So, now, what happened after the Younger Dryas? Well, I ran into a paper that discussed a Y chromosome bottleneck. And, the paper said, well, we have found a Y chromosome bottleneck, and this is due to cultural changes. And they were saying, well, there were harems and, domination by some people that did not let others reproduce. And so they, by having this culture of restricted births, this created a reduction this created the Y chromosome bottleneck. But when you take a look, and this happened in Central Asia, it happened in Europe, it happened in South Asia, it happened in a little bit in Africa, but you can see that everything started right at the Younger Dryas boundary. And initially, it starts dropping slowly, and then the Y chromosome bottleneck really starts. And it actually is at the deepest level about 5 or 6 to 7,000 years ago. Wow. Now, there is a paper by that shows that cold weather inhibits births of males because they die in utero. Okay, so you have.
Really?
Oh yes. As a matter of fact, let me first show you this diagram. The mitochondrial DNA doesn't show any decrease. You see 12,900. You see 10,000 year ago mark, and there is no decrease in mitochondrial DNA. So this is why it said, well, only the males were restricted. But take a look at this slide. See, 12,900 years ago, you can see there's actually starting around 20,000 years, which is the end of the ice age, when you start having the meltwater pulses like 1A.
1B.
Yeah, but meltwater pulse 1A right around here, okay, the 14,000 year mark. But see, then the Younger Dryas, the ratio of women to men goes to 17 to 1. Can you imagine that? 17 women?
Sounds
For
ace.
each man. But see, the question is, okay, how did the population keep on growing? Well, it turns out that there were many happy men then, even though there were few. This is the only explanation. One man can make 17 women pregnant.
I could
And
do
so
20.
And so the population keeps increasing, even though there are fewer men. This chart also shows us, notice 70,000 years ago.
Oh, what happened there?
The Toba volcanic eruption.
Oh, wow.
You remember, it has been said that when Toba volcanic eruption occurred, the number of breeding pairs may have been reduced to 10,000.
Yeah.
And so it's written in our genes. This is our genome is indicating that this Toba was a real event, that actually affected humans. And, again, with some lag time, that ratio of females to males goes to 6:1. And so it looks like the male genome is really fragile. And cold weather really affects the human male ratio.
That's amazing. I've never heard that before.
Turns out we were the weakest sex all along.
Yeah, we are the weakest sex. Yeah.
You're not kidding. No, here, this chart shows the younger dryas, the YDB, okay? And the following, it has been overlaid with this chart of the female to male ratio. And you can see that as the beginning of agriculture, this is when this ratio was the highest. And so it means that the women farmers really helped our civilization. There have been some studies in South America showing that women were hunters and that they were buried with hunter kits. And so the women took over many functions during this hard times.
Before the Holocene, do you think there could be other factors as well? I'm thinking about hunting and predation and war and things like that, which would have pushed the ratio down for us blokes.
Well, there's also cannibalism,
Cannibalism?
You get younger, you look too good, or people die, they freeze to death, and hey, we cannot let this go to waste. So cannibalism is not out of the question.
Wow.
When there is great need, nothing goes to waste. In looking at the Carolina Bays, we had, I have like 5,000 subscribers on my YouTube channel. And one of them, Eric Brown, found this in Oklahoma, in Tulsa, near Tulsa. And when I looked at it, I said, wow, these rims have been manicured. They are not the natural chaotic from an impact. Somebody has actually modified them. And then I looked and I saw these lines inscribed to the left of the ellipse. And when I coordinated that with using the NOAA solar calculator, I found out that by bisecting this angle of this these lines that are carved points to this summer solstice, and the lines that are horizontal actually are the vernal and autumnal equinoxes. There was no line for the winter solstice, but it turns out that it's at 90 degrees to this line, the upper line that's inclined from the along tangent to the upper part of the ellipse. And so it turns out that this is a solar observatory in Tulsa, Oklahoma. We have contacted some geologists, some archaeologists, and we're trying to contact some Native Americans to see if there are any legends or anything that says anything about this site. The ellipse itself is as big as a little bit bigger than the Rose Bowl. So like 300 meters or something like that. So it's huge. And in order to show that it's not just not a human artifact, I went and I found one more elliptical basin in Oklahoma. So apparently, the story that I'm telling about this is that some ice boulder ejected from Saginaw Bay or Lake Michigan came down and crashed into and made an inclined conical cavity that became this elliptical feature. And then some Native Americans recognized it as being something special and built a solar observatory around it. So, right now there's a lot of archaeological work that needs to be done on this one. But it's one of the interesting things about having a website or a YouTube channel that talks about the Carolina Bays, because you never know what you're going to find. Something interesting always pops up.
Cool.
Now, some people have been saying there were multiple impacts all the way down, causing all these meltwater pulses and sea level rise. And when I looked at the meltwater pulse 1A, which is caused by the Lake Missoula flooding in the Pacific Northwest. All this, not Badlands, but they call it, all this flooded area was subject to a great cataclysm, which inundation, and which devastated the region. And right now you have a lot of rocks that were carried within the ice boulders that ended up here. You have a lot of those erratic boulders and coulees that were carved by the running water. And when people suggest an impact or may have released the water for this, I always come up against the fact that the British Columbia and the Yukon have a lot of volcanoes, and you have the Pacific plate pushing against the American plate or subducting under the American plate. And from time to time, we have like this volcanic eruptions, Mount St. Helens and so forth. And it is not unlikely that a volcanic eruption under the Cordilleran ice sheet released the water to fill Lake Missoula and Lake Columbia to create those, to fill those lakes that later created or devastated the Northwest, Pacific Northwest territory.
Right. So the theory is that they were held back by like an ice dam, and then eventually the waters bust through.
Yes. But you cannot invoke this extraterrestrial impacts all the time. When there is a more plausible explanation in volcanism. And this happens in Iceland all the time. You have they have a special name, Kajafults, or I forget what they call them, where some volcanic eruption actually melts a glacier, and you have the glacier melt water, creating flooding. And if you look at what's happening in Iceland, that's happening all the time.
Yeah, it's just a question of scale, I guess, with the Missoula floods.
Yes. And so basically, that's all that I have, and a lot of my my YouTube channel has a lot of videos with different aspects of the Carolina Bays and the questions about that people have brought up. How did this happen, or how did that happen? And I have tried to answer them because a hypothesis cannot be a good hypothesis if it cannot answer the questions that are brought up against it. It has to be able to hold up. Otherwise, it's not a good hypothesis.
True. Yeah, there's loads of good stuff on your YouTube channel. The link will be in the show notes as usual. And I like the video you did just now. You've waded into the ancient apocalypse debate as well.
Yes, sometimes I look at like I looked at this Y chromosome bottleneck, which is really not Carolina Bay, but it's related to the cataclysm. And when I think that the humans have been around for 200,000 years, and I think that the historians say that the culture is only like 10,000 years old, I say, what were these people doing with intelligence like ours and ambitions like ours, doing for 190 years, 190,000 years, with just twiddling their thumbs? No, of course not. They had to come up with Toba. They had to survive cataclysms like a cataclysm like what I have mentioned here. It just wipes out all your culture. It wipes out everything that you have. There's nothing left. You cannot even dig and find anything. Just look at this disasters with tornadoes in Florida or Louisiana. People are just wiped out. And they go and at least they can dig a few things that are not buried. But when you have this bombardment that kills everything, including vegetation, buries everything, and makes it into a pulp, there's nothing there. The only people that could be here are those that came from outside, from the West, where there was a possibility of surviving the cataclysm.
Or from
anybody
from the South, I guess.
From the South, yes. Yeah.
Wow.
So
this has been fascinating, Antonio. I really like the way you put the scale on it, the way to try and get your head around how cataclysmic this would have been. It's
of cataclysm.
Terrifying, absolutely terrifying. Love it.
Yeah, amazing. Thank you, Antonio.
Yeah.
Well,
thank you for inviting me.
No, it's great. I really appreciate your time. We've done an hour and 10 already, so we should probably let you go and get on with your day.
Well, thank you very much.
But yeah, it's been a pleasure. And check out the links in the show notes, chaps. Check out the book, YouTube channel. Follow Antonio on Twitter.
Yep.
All the links are there. And we'll sign off now. We'll be back in 10 minutes or so for part 2. But just stay on the line for us 1 minute, Antonio.
Okay.
And we'll see the rest of you very shortly.
Bye. Bye.